Welcome back, YouTubers. Let's go ahead and get started on a new topic called systems of equations. Now, a system of equations is, just like it sounds, plural. Now, let's think about all the equations you've had to solve last semester. You know, you most likely used x quite a bit in your classes. So let's say we had something like x plus 7 is equal to 13. Well, you learned how to solve that just by subtracting 7 from both sides. You also would have done something like y times, or 4y is equal to negative 16. And you learned to divide both sides by y. You could have combined a few ideas together and said that 3r plus 6 is equal to 18. And you have learned a two-step equation there. You know, subtract 6, divide by 3. Now, you could have even done something more difficult and put the variable on both sides of the equation and said that negative 4x plus 7 is equal to 2x minus 17. And then that's a slightly different problem. You've got to get the x's on both sides. But in every single case, all of them have only had one type of variable in it. Now, I say one type of variable and not just one variable, because in this case, there are technically two x's there, but there's still only x's. You're never combining x's and y's into the same problem. Now, you also may have done something like this, where you had 2x plus y is equal to 7, and you would have tried to graph that problem. And before you graphed it, what you would have done is you needed y by itself, so you transposed the y, so you said transpose the x, y equals negative 2x plus 7. You would have said that this was m, or your slope, this was b, or your y-intercept, but in this case, we're graphing, we're not actually solving. You know, solving would mean that in the end we had something, for example, y is equal to negative 4, and that would be my answer. In this case, your answer is going to look like, well, there's 7 and then negative 2. Your answer is going to be a graph. The problem is that if you have two variables in an equation, you can't actually solve it. The reason is that, well, I could plug in a whole bunch of different values for x's, and every single one of them would give me a different value for y. So that's where systems of equations come into play. A system of equations uses multiple equations and multiple variables at the exact same time. Now, it's called a system because we have several things going on at once that are related. An example of that would be something like this. X plus y is equal to 7. Now, again, I can't solve that directly because, well, I could put in 0 for x, and then y would be 7. I could put in 1 for x, and then y would be 6. There's just a whole bunch of different answers. Now, however, if I combined it with this, x minus y is equal to negative 4. This little curly brace shows that these two are connected together as one idea. These two equations together is called a system. And using the different techniques we're going to talk about in future videos, we'll be able to solve this and be able to get down to the answer x equals and y equals and figure out what the exact numbers are. Now, we're not going to actually learn how to solve these just yet. The first thing I want to talk about is, how do I know which method to use? We're just be identifying things right now, and later on we'll actually go through the methods of how to get those things set up. But before we get into that, we got to review what standard form is, and what slope-intercept form is. Now, if you remember, standard form was something like this. 3x minus 4y is equal to 16, where you had the x's and the y's on the left, and then your constant term on the right. Slope-intercept was this one. The y equals mx plus b. Y equals negative 1/3 x plus 7, where your slope is 1/3 and your y-intercept is 7. Now, there's several different styles of systems that we could see, and they're all going to be based on either standard form or slope-intercept form. Now, one thing that you could see is something like this. y is equal to 4x plus 6, and y is equal to negative 3/7 x plus 4. Now, when you look at both of these, you're going to see that, well, what form are they in? This top one is in slope-intercept. The bottom one is also in slope-intercept. Well, whenever I see two slope-intercept forms, what that tells me is I want to graph both of these. Graphing is one of the methods that I use. So two slope-intercepts means I'm going to check out graphing. So if you have something that uses two slope-intercepts and you're looking for how to do that one, go ahead and click down on the playlist to the one that talks about graphing, and you can see how to do that one. Now the next thing you're going to notice is stuff like this. 2x minus 3y is equal to 8, and 4x plus 6y is equal to 13. In this case, I've got standard form and standard form. If they're both in standard form, well, that one is going to be a method called elimination. And once again, if you're looking at a problem that looks like this and you want help on solving it, well, you can fast forward to my elimination videos. There's actually 3 of those. Go ahead and watch those and you can see how to go through the elimination step. Now, that's if they were both slope-intercept or both standard form. What if it was mixed? What if I had y equals 2/3 x minus 7 and 2x plus 7y is equal to 9? In this case, I have a slope-intercept form and I have a standard form. Well, when they're mixed like that, that's going to be most likely a substitution problem. And once again, you can go and check out my videos on substitution. Now, something you got to keep in mind on this substitution, when I say slope-intercept form, it doesn't necessarily have to be exactly slope-intercept. For example, you could have one that looks like this. X equals 2/3 y plus 6, and 3x minus 7y is equal to 8. In this case, we definitely have a standard form right here. Now this one is not exactly slope-intercept form, but it still follows the same pattern, so I'm going to call this one a slope-intercept. I call it a sort of slope-intercept. It still will be a substitution problem. I can't spell substitution half the time. Okay? Now there's one more type, and that's one that doesn't quite fit any of those. Okay? Let's look at 2x minus 9y is equal to 1, and 4x is equal to 3x minus 7. Now in this case, again, I've obviously got a standard form there. This one doesn't quite fit any of the ones above. It doesn't quite fit standard form. It doesn't quite fit slope-intercept. So on this one, I call this one the gray area because there's not a specific one. These are not going to come up very often, but we'll come back at the end and we'll talk about how to handle these gray areas. For now, most of the problem your teacher is going to give you on the assignments and the reviews, they are most likely going to be one of these 4 types. Okay, these we'll come back to at the end, and I'll call it the gray area problems.